In this lecture, we're going to learn about return type deduction in functions. Return type deductions in functions is really about one thing: letting the compiler deduce the return type of a function, judging from the return statements in your function. Let's look at a simple example here. Here we have a function called process number, and it is going to take one parameter n of type int, and notice that the return type is auto. What we mean here, we want the compiler to deduce the type of the return type for this function. And the compiler is going to deduce this from what we return here. If you look here, we are returning integer literals. So the compiler is probably going to deduce to be a function that returns integer. This is what return type deduction is really all about. Simple, right? Let's look at another example here where things might not go so well. We have again the same function here, and we are deducing the return type. But notice that what we return here are inconsistent types. In the first branch of the if statement here, we are returning an integer literal. And in the second line here, we are returning a floating point literal. This is going to be a double literal. So the compiler is really going to be confused here. And it is going to give you a compiler error because it can't really choose between int and double for the return type of this function. When you are doing return type deduction, make sure that your return types are consistent. If they are not, you're going to get a compiler error, and you're going to have to fix this one way or the other. One way to fix the problem we had in the last slide is to change the function not to return auto. For example, if you change the function here to return double, then the compiler is going to know that it is going to insert an implicit conversion from whatever you return to double if that's possible. In this case, we can transform integer to double, so this is going to work fine. And the second return statement is going to return a double literal. We don't need to do any transformation, and this is going to compile and work fine. So this is one way you can get around the inconsistent return type problem when using return type deduction. The solution might be not to use return type deduction at all. Another solution is to explicitly cast to one type. For example, here we are turning our integer into a double, and the other guy is going to be a double. Now the compiler is going to be happy because it's going to see that your return types are consistent. You are returning double on the first line here, and you are doing the same thing for the second line here. So the compiler is going to deduce double as the return type of this function here. This is another way you can get around this problem. Okay, now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is function return type deduction. We're going to grab our template files pretty quick and put them in place. And we're going to open this guy up in Visual Studio Code. Let's drag and drop on top of Visual Studio Code here. This is going to open our project or our folder. And we're going to grab the main CPP file here and clean it up a little bit. Let's close the left pane here. The first thing we're going to do is to set up our function to do return type deduction. And you do return type deduction in a function by specifying your return type to be auto like we have here. And if we call this function, if value is less than 10, it is going to return 22. If it's not less than 10, it's going to return 55. Okay, now we're going to go in the main function and see what the compiler deduces for this function here. One way to do that is to use auto type deduction. Again, we're going to say auto and say result. And we're going to say process number. And we're going to give it a number. Let's give it a 7, for example. We can use a number literal here. Once we do this, we're going to print out whatever result we got from the function. Really easy. We're going to say result, and we're going to say result here, stdendl, and we're going to print the size of the result here. Let's do size of result. And we know that the size of int on our system is 4. The size of a double is 8 on this system, and we're going to be comparing those results to what we get here. Let's do that pretty quick and put in the sizes of int and double. And now we can run this program and really get information about what is happening here. Let's build it. We're going to see what we print on the terminal. The build is good. We can bring up a terminal and clear and run rooster. Now we're going to see that result is 22. The size of result is 4. The size of int is 4. The size of double is 4. From this, we may know that the return type was deduced to be int. And we could guess that because we knew that our return types were consistent and we were returning integers in these two branches of our if statement here. So this is the syntax to use auto type deduction. The return type has just to be auto, and the compiler is going to look at your return statements and deduce the return type of the function here. Okay, now that you know this, I want to show you a few problems you need to be aware of that might come on your way if you are using return type deduction. Let's say that this is the right way to do things. Okay, and we're going to comment this out and put in a problematic piece of code. Let's make sure this is in a block comment like we have here. And we're going to go down and put in another function called process number. But although this function looks very similar to what we had on top here, notice what we are returning. We are returning an int literal and a double literal. So the compiler is going to look at these return types and realize these are two different types, and it's going to be confused as to what it's going to deduce as the return type of this function here. And if you go in Visual Studio Code in the Problems tab here, you're going to see deduced return type double conflicts with previously deduced type int. So the compiler is going to look at the first return statement here. It's going to deduce an int. When it hits the second line here, it's going to deduce double. So the compiler is going to be confused and saying, is it a double or is it an int? I don't know. I'm going to give you a compiler error because your code doesn't really give me enough information to carry out successful return type deduction. If we try to compile this program, we're going to get a compiler error, and we're going to see that here, inconsistent deduction for auto return type int and then double. I think this is very specific and we need to solve this problem. One way we have to solve the problem is to not use return type deduction at all. We can go here and change the return type either to int. If we do that, the compiler error is going to go away because the compiler is going to be able to turn this double literal into an int. So the compiler is going to insert a narrowing conversion from double to int here, and we're going to get a 33. This dot one is going to disappear because integers cannot represent decimal points. If we try to build this program, the build is going to be good. You see, build is successful. And if we try to run this program, we're going to get 22 here. We want to hit this branch so that you see that we have done a narrowing conversion from double to int, and the dot one here has disappeared. So for that, we need to call the function with something that is not less than 10. Let's put in 17. Why not? We're going to build again. The build is good. We can clear and run rooster now. You see that we have 33 here. Hopefully you see that the compiler has done a narrowing conversion from double to int. If you want, you can also make this double. You can really do whatever you want, and it is going to work equally well. Let's run the task to build with GCC. The build is good, and the compiler is going to deduce double as the return type. You see, size of result is 8. Now the return type is double. I should say the compiler is not going to deduce. The return type is going to be double, and we're going to deduce that here, but this is not return type deduction. This is simple bare auto type deduction here. Okay, this is one way we can solve the problem with inconsistent return types, but we can also use auto and do the transformation ourselves. If we do this and, for example, say static cast, and we cast to double, and what we cast is this 22 here, this is going to work. Now the compiler is going to see that this guy is going to be a double expression, and it's going to look down here and see that this is a double literal. So the compiler is going to be happy. Let's try and build this and see if the compiler can help us get rid of these squiggly lines. It isn't. We have a compiler error here. We should use angle brackets. And if we build again, I think we're going to go through. Let's use the GCC. You see the build is good. The squiggly lines are gone. And if we run this program now, it is going to be deducing double because our return types are consistent now. So let's do that. We're going to build and run. The build is good. We can clear and run rooster. Now we are having a result of 33.1. You see that we are deducing double, and the size of result is 8, and this is proving that our return type is now double. Okay, this is really all we set out to do in this lecture, showing you how you can set up auto return type deduction for your function. And we showed you that you could run into serious problems if you're not careful and making your return types consistent. Okay, if you are careful about these little things, you're going to use function return type deduction without a problem, and this might make your code easier to set up and use. Sometimes you don't really have enough information to know the return type of your function, and function return type deduction might come in handy in those cases. For now, we're going to stop here in this lecture. In the next one, we're going to see how you can do function return type deduction with references. Go ahead and finish up here and meet me there.